Good morning, students. How are we? Today we are going to learn how to find number of factors of a given number. These types of questions are quite common in SSC exams, where they ask you to find number of factors of a given number. There may or may not be some conditions involved, but we are supposed to find number of factors, okay? So we are going to learn about this. Let's start. As we can very clearly see that 63 has 1, 3, 7, 9, 21 and 63 as its factors. In total, there are 6 factors. But if we are asked to find all the factors of 64800, that would be tricky because it is easily going to be more than 20 or 30. Now that will be difficult for us to find. So what we instead do is we prime factorize. We write 64800 as 2 to the power 5 times 3 to the power 4 times 5 squared. Now if we observe, we can easily say that 2 to the power 5 has factors 2 to the power 0, which is 1, 2 to the power 1, 2 to the power 2, 3, 4 and 5. All these can be considered the factors of 2 to the power 5. Similarly, 3 to the power 4 has factors 3 to the power 0, 1, 2, 3 and 4. All of these can be considered the factors of 3 to the power 4. And for 5 squared, it would be similar, 5 to the power 0, 1 and 2. Now, if we apply some permutation combination, we'll say the total number of factors of 2 to the power 5 is 6. For this, it is 5 and for this, it is 3. We multiply them, we get 90. Therefore, we can say the total number of factors for Alexa, stop. Total number of factors for 64800 is 90. Simple. Now, if you observe, what we have done is we have increased the exponents by 1 and then multiplied them. Increase the exponents by 1 and multiply them in order to find the total number of factors. So we do not need to write this every time. We'll just say take the exponents, add 1 to them and multiply them. We get 90. That is how we find the total number of factors. Now, the question arises, what if they would have asked us to find the total number of even factors? Let me do one thing. Take this, copy this item so that I can paste it anywhere. Alright. What if they would have asked us to find even factors, total number of even factors? We know that any number can be considered even if it just have one factor as 2. So what we do is we take 2 out of the equation. We say 2 to the power 4, 3 to the power 4 and 5 to the power 2. We just took one of the 2 out so as to make any factor even. Now we'll use the same logic for this section. We'll say, let us multiply all the exponents by increasing them by 1. Add 1 to 4 again. Add 1 to 4 and add 1 to 2. That would be 25, 3s are 75. Simple as that. Now, what if they would have asked total number of odd factors? If they would have asked total number of odd factors, we would have said any presence of 2, any presence of 2 would make the factor instantly even. So we are not even going to talk. We are not even going to talk about 2 to the power 5 in any scenario. We'll just remove the entire 2, which are the factors of the number. We'll just talk about this section. Again, we'll increase the exponents by 1 and multiply them. You get 15. Now there is an interesting fact over here. If you observe, total number of even factors is 75 and total number of odd factors is 15. You add them up, that is 90. That is anyway what we were getting as total number of factors. Simple as that. Now, what if instead they would have asked us to find the total number of factors divisible by 6? Actually, we have learned this. If you observe, what do we mean by total number of even factors? This simply means that we are finding total number of factors which are divisible by 2. Right? Even means divisible by 2. And in this case, what we did was we took a 2 out of our entire equation and solved it. Similarly, we are in this case going to take 6 out of the equation. 6 is made out of 2 and 3. So we'll take 1, 2 and 1, 3 out of the system. We'll write 2 times 3. If I take 1, 2 out, we are left with 2 to the power 4. I take 1, 3 out, we are left with 3 to the power 3 times 5 squared. We do the same thing which we generally do. We take the exponents, add 1 to them and multiply. 4 plus 1 times 3 plus 1 times 2 plus 1. That turns out to be 3 4s are 12, 5s are 60. Simple. Alright. What if they would have asked us to find the total number of factors which are perfect square? Now, in order to understand how to solve this question, let me give you a few examples. 7 squared is a perfect square, right? 7 to the power 4 is a perfect square. 7 to the power 8, 7 to the power 6, all of them are perfect square. But what about 7 to the power 3, 7 to the power 1? These cannot be considered perfect square. Why? Because their exponents are odd. Simple as that. This clearly signifies that the exponents must be divisible by 2 in order to make something to be a perfect square, right? So in this case as well, what we are going to do is we are going to divide the exponents by 2. If you divide 5 by 2, you get, let me write the factors first of all, 2 times 3 times 5. Again, we want the factors, the exponents to be divisible by 2. So we divide the exponents by 2. Divide 5 by 2, you get 2.5. You divide 4 by 2, you get 2. Divide 2 by 2, you get 1. But again, you cannot take a decimal number to be your exponent. Why? Because pair of 2.5 is not feasible in this case. So instead we take integers, just the integers. If you get 2.5, you directly say that I am going to take just 2. If it would have been, let's say, 3.33, you would have taken 3. All right. Now, you have your system. What you are going to do is add 1 to exponents and multiply them. That would be 9 2s are 18. This is the total number of factors which are perfect squared. Now, total number of factors which are perfect cube. Similar question, I'd say. Now, we are very clear, since in order to make something to be a perfect square, the exponents needed to be even, that is divisible by 2. In order to make something to be a perfect cube, the exponents need to be divisible by 3, right? Like 7 to the power 3, 7 to the power 6, 7 to the power 9. Simple as that. We are going to apply the same approach over here. We are going to divide the exponents by 3. Over here, the exponents are 5, 4, and 2. We divide, let me write the factors first of all. We divide the exponents by 3, we get 1.66, 1.33, 0.66. But we are supposed to take just the integer part, so we will leave the decimal part out and just keep the integer part. Now, it is very clear what we'll do is we'll add 1 to our exponents and multiply them. That is 2 times 2, which is 4. Simple as that. That means there are just 4 factors which are perfect cube. Total number of factors which are perfect square. Isn't that clear that in order to check if the factors were perfect square, we check it with the divisibility of 2, and for cube we checked it with the divisibility of 3. In order to check something to be perfect square as well as perfect cube, we'll check with the divisibility of 6. In short, we are going to divide the exponents by 6. We will divide the exponents. First of all, let's write the factors as they are and divide the exponents by 6. As you can very clearly see, we are going to get 0 point something for all the cases, and anyway we are supposed to take integers, we'll just write 0, 0 and 0. So total number of factors would be multiply all the exponents by adding 1 to them. You are going to get 1. So only just one factor of the entire 90 factors of 64800 is a perfect square as well as a perfect cube. Simple. Now, we can be asked to find sum of all factors. We learned how to find total number of factors, but we can be asked to find sum of all factors. How do we do so? Very simple. We learned that these are all the factors of the factor 2 for 3 and for 5 respectively. We just add them in order to find the sum of all factors. What we say is, let's start with 2 to the power 0, add all the way up to 2 to the power 5. Similar goes for 3 and for 5. Add all the factors of 2, 3 and 5 respectively and multiply them. That is how you find sum of all factors. Now, you can apply the sum of all terms in GP over here, geometric progression, which we learned in the previous class, or you can directly solve it. It is not that lengthy. This would be 32, 16, 8, 4, 2, 1. That would be 63 times 81, 27, 9, 3, 1. 121 times 25, 5, 1, 31. Well, we are not going to multiply this. You can deduce the answer by using unit digit or decimal sum when you are given options, all right? This is how we find the sum of all factors. Let me explain that once again. You take all the factors of 2 from 0 all the way up to 5, all the way up to 5. Again, you take all the factors of 3 from 0 all the way up to 4. Factor of 5 from 5 to the power 0 all the way up to 5 to the power 2. You add them up, you multiply, you get sum of all factors. You don't need to do all of this every time. Okay. What about total number of even factors? Sum of all even factors. We are going to do exactly the same thing. Let me copy this stuff actually. Let me copy this. Even if you are asked total number of even factors, you are going to write exactly the same thing. Exactly the same thing. The only difference would be that if you remember, while calculating the total number of even numbers, we took one of the two out of our system just to ensure that all of the factors are even. We are going to remove and counteract for that part of 2. So we are going to remove one of the two starting from 2 to the power 0. Remove this and then we are going to solve. Okay, that would be that was 63, that would become 62. Right, 62 times 121 times 31. Simple. What if they asked us the sum of all odd factors? We are still going to write the same stuff. Exactly same stuff. No difference at all. But if you remember, when we were calculating the total number of odd factors, we removed all the factors of 2. We removed all the factors of 2. Here as well we are going to do the same. We are going to not talk about any of the factors of 2. We'll just counterpart for the factors of 3 and factors of 5. That is, this was, how much was this? 121 and 31. Simple. Sum of all factors divisible by 6. What we do is we do the exact same thing which we did in earlier cases. We paste the same thing. Now, I'll again like to remind how did we came to this conclusion. We said we are going to write all the factors of 2 from 2 to the power 0 all the way up to 2 to the power 5. All the factors of 3 to the power 4 from 3 to the power 0 to the 3 to the power 4. Same goes for 5. Now, we took 2 and 3 out of our system because we wanted the factors to be divisible by 6. So we are going to take 1, 2 and 1, 3 out of this system as well. We'll remove 2 to the power 0 and 3 to the power 0, which would make it 62 times 120 times 31. Simple. Again, we are not going to solve it. There will be options for you to eliminate from. How do we find sum of reciprocal of factors of n? For example, for 10, there would be factors 1, 2, 5 and 10. They would ask us to find the sum of all the factors by making them reciprocal. This is easy for a smaller number having very minimal number of factors. But what about a number like, what was the number? What was the number? 64800. That would be difficult, right? So we have a formula which says you write the sum of all factors and divide it by the number itself, 64800. Sum of all factors, if you remember, was 63 times 121 times 31, right? I'll make you understand. Right, this is sum of all the factors, 63 times 121 times 31. So whenever you are asked to find the sum of reciprocal of all the factors of n, what you do is you write the sum of all factors and divide it by the number itself. You get the answer. What if you are asked to find the product of all the factors? You apply this formula which says write the number first of all, which is 64800. 64800. Total number of factors. What was the total number of factors? It was 90. The first question which we solved, and divided by 2, which we get to be 64800 to the power 45. Anyway, we are not going to solve, that will be too big. You will be given options to choose from, okay? That was all. These were all the questions which could be asked in your exams. All the types we have covered. Let us recall whatever we have learned in this class. We learned total number of factors, how to find total number of factors, 1, how to find total number of even factors, 2, how to find total number of odd factors, 3, factors divisible by 6, 4, factors which are perfect square, 5, factors which are perfect cube, 6, factors which are perfect square and perfect cube, 7, sum of all the factors, 8, sum of all the even factors, 9, sum of all the odd factors, 10, sum of all the factors divisible by 6, 11, sum of reciprocal of factors of n, 12, and product of all the factors of n, 13. So in total we learned 13 types of question, and these are all. You don't need to learn a single type of such question ever again. Just need to practice. All right, if you understood the class, like the class, please hit the like button, comment if you have any suggestion, and please do watch the entire playlist of number system, which is almost complete. There will be 1 or 2 more lectures on this one, and go visit the PYQ sessions. Thank you. Have a nice day.